is the power. What is your power or the n? And here are its coefficients. If your n is 1, right? So what it will be? It will start from 1C0, 1C1, right? So 1C0 will be equal to what? 1 factorial, 0 factorial, 1 factorial, and that's precisely your 1, right? Then 1C1 will be equal to 1 factorial, 1 factorial, and when you subtract the 2, so that is just 1 factorial. So these guys are same, right? Now, if your n is 2, then you have 2C0, 2C1, 2C2. So first it will be 2 factorial, 0 factorial. When you subtract the 2, it will be 2 factorial and it's 1. Then here you have 2 factorial, right? 2 factorial. When you subtract the 2, 0 factorial. So look, these guys are same, right? And you can just notice one thing, that it's in the format of NCR is equal to n minus r, right? So when you subtract 2 minus 0, it's 2, right? So that's what you are getting. Then you have 2 factorial, 1 factorial, 1 factorial. That's 2, 1 times 1, and that's your 2. Okay. Then you have n is equal to 3, 3C0, 3C1, 3C2, 3C3. That is equal to 3 factorial, 0 factorial. When you subtract 3 from 0, it's just 3 factorial. That's equal to your 1. This one is 3 factorial, 1 factorial, 2 factorial. So that's basically 3 times 2 factorial, and that's 1 factorial times 2 factorial, and that's equal to your 3 factorial. For this one, you have your 3 factorial. Just write 2 factorial as it is. Then when you subtract the 2, it is your 1 factorial. Can you see from here itself, the expansion of 2 is same, right? So hence the symmetry property holds. This is equal to your 3. This is your 3 factorial. Then this is your 3 factorial, and this is your 0 factorial. These two are same. So that is your 1. Then you have n is equal to 4. 4C0, 4C1, 4C2, 4C3, and you have 4C4, right? So what is your 4C1 equal to? 4 factorial, 1 factorial. When you subtract the 2, 3 factorial. Then this is 4 factorial. Now 4 factorial can be expanded. So 4 times 3 factorial upon 3 factorial. That's just your 4 factorial. 4C2, that's your 4 factorial. 2 factorial. When you subtract the 2, it's again 2 factorial. So that's 4, 3, 2. So 2 factorial times 2 factorial. That's your 6. Then you have 4 factorial, 3 factorial, and 1 factorial. That is equal to your 4 factorial, 4 factorial, 4 factorial, 0 factorial. And that is equal to your 1 factorial. Can you notice that these guys are same? What is 4c? 0. Okay, we left 4c 0. So it's 4 factorial, 0 factorial and 4 factorial, that is equal to your 1. I'll do for one more. N is equal to 5. That is 5c 0, 5c 1, 5c2, 5c3, 5c4, and you have 5c5. Okay, let's expand this. Then you have 5c0 is 5 factorial upon 0 factorial. When you subtract the 2, it's just 5 factorial and it's 1. 5c1, it's 5 factorial, 1 factorial upon 4 factorial, and that is 5 times 4 factorial, 4 factorial, and that is your 5 factorial. 5c2, it's 5 factorial, 2 factorial, 3 factorial. So that's 5 times 4 times 3, and that's 2 factorial times 3 factorial, and that's your 10. Right? Then 5c3, that's your 5 factorial, 3 factorial, 2 factorial. Look, the expansion of these two are same, and hence this will be equal to your 10. 5c4, it will be equal to 5 factorial, 4 factorial, 1 factorial. That's basically 5c5 will be equal to 5 factorial upon 5 factorial, and when you subtract the 2, it's 0. So that's just 1. Okay, so we have these values. Let's just arrange them. Let's see what it gives us. When n is 1, so you get 1 and 1. When you have 2, then you get 1, 2, 1. When you have 3, then you get 1, 3, 3, 1. When you have 4, you have 1, 4, 4. It's 1, 4, 6, 4, 1. When you have 5, you have 1, 5, 5, 10, 5, 1. Then you have 1, 5, 10, 5, 10, 10, 5 and 1. I have just arranged all the things that I have got using the formula NCR.